Here we have a question. A function is given. This is a piecewise defined function. What piecewise defined function means that if we have a number line, the function here is saying function is x plus 2 if x is less than 3. So function is defined differently before 3 and after 3 the function is defined different. So before 3 the function is defined as x plus 2 and after 3 the function is defined as 12 minus 2x. Okay, so the question is to check whether the function is continuous at a number or not. For these kind of problems you need to first find the left limit of the function, right? Always whenever the piecewise defined function, find left limit and the right limit separately, then see if they are equal, then the limit will exist. Okay, left limit, what does it mean? That x is approaching to 3 from left side. That means x is a little smaller. It's very close to 3, but it's still a little smaller than 3, right? If it is smaller than 3, which function are we going to use? X plus 2. So limit x approaching to 3 from left side. The function we are going to use is x plus 2. Why? Because x is on the left hand side, so it's a little smaller than 3. It's very close to 3, but it's a little smaller than 3. So when I put 3 in there, 3 plus 2, answer is 5. So the left limit is 5. Limit of the function as x approaches to 3 from right hand side. Right hand side meaning we are reaching 3 from right hand side. That means we are getting very close to 3 from right hand side. So we are very close to 3, but we are still on the right hand side. If we are on right hand side, that means x is more than 3. Therefore, the function used to find this side of the limit would be 12 minus 2x. So now you put 3 in there. 12 minus 2 times 3. 12 minus 6 will be equal to 6. Now you guys notice this limit is not equal to this limit. One is 5, the other one is 6. Therefore, the limit does not exist. Limit x approaches to 3 of the function does not exist. If this limit does not exist, the function is not continuous at 3. To remind you guys, the definition of continuity is 3 conditions. Limit exists at a, and this limit exists and the limit is equal to f of a, where f of a also exists, right? So 3 conditions: limit exists, value of the function at a exists, and they are equal. In this case, the limit only doesn't exist. We didn't even need to check the value. The function is not continuous at this number. Let's practice one more problem. This is a function given, and the question is to check if f is continuous at x is equal to -1 and 2. There are 2 points. So let's first talk about x equal to -1. Remember, the limit continuity's definition is the limit at a should exist, the value at a should exist, and they should be equal. Then f is called continuous at x is equal to a. So let's try at -1. So we need to find, if we have a piecewise defined function, always find the left limit of the function. Now, when x is approaching to -1 from left side, it's very close to -1, but it's from left side. So x is less than -1. Therefore, the function used in this case would be this one, cube root of x. That will be cube root of -1, basically -1. Find the right limit. So this is left. Now find the right limit. X is approaching to -1 plus. Plus means from right side. X is approaching to -1 from right side. That means it's getting very close to -1, but it's on the little right side. Right side means x is more than -1. Okay, so that means function used for the right limit has to be, because x is more than -1, is x. When I put -1 in there, it's -1. These two numbers are equal to each other. Left and right limit are equal. Therefore, limit of the function as x approaches to -1 exists and is equal to -1. Now we also need to find function's value at -1. For the function's value, you need to check where is equal sign with -1. That's on the first one. So therefore, for that, you need to use the first function, and that would also be -1. So the value also exists, limit exists, and they are equal to each other. Therefore, f is continuous at x is equal to -1. Let's check on 2 now. X is equal to 2. So we need to find the left limit at 2. Left limit means we are approaching, x is approaching to 2 from left side. It's getting very, very, very close to 2, but it's still on the left side. Therefore, x is less than 2. Therefore, the function used will be this. When I put 2 in there, that will be just 2. Limit x is approaching to 2 from right side. What does that mean? That means we are getting very close to 2 from right side. Very, 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 very close. When we do very close, it's on the right hand side, it's little more than 2. Therefore, the function used will be this one here. When I put 2 in here, 2 minus 1 whole square, 1 square is 1. We notice that this limit is not equal to this limit. Therefore, limit x approaches to 2 of the function does not exist. If this does not exist, it cannot be continuous, because continuous, we need, the definition is it has to, the limit has to exist, the value has to exist, and they have to be equal to each other. In this case, only the first property is not satisfied. Therefore, we're gonna call f is not continuous at x is equal to 2. We don't even need to check the value of the function at 2 in this case.